Okay, so I had to put this in Vim so that I can pick up this data later and everything. You can see that it's been written to the YouTube notes.txt, alright? I'm going to show you me not being a vibe coder. Okay, so I went to this and everything, and I sent him the script that it generated, and I asked him to explain it to me line by line. Okay, so this is a PowerShell block comment. So below, when he started explaining parameters, I asked him to explain parameters to me, right? Like the param command in PowerShell and what that does and everything. So let's scroll down to that. Turn off reader mode for this. Okay, so what it did here, I said, what is a parameter? And it said a parameter is a named input slot for code. Now, I knew this, but I wasn't. I was asking the question just to be doubly certain about it. So, you know, param string. Oh, okay. See, I'm looking at this block of text, and it confused me at first, but now I'm seeing it. Okay, well, that's down to just not familiarity with PowerShell's, you know, syntax, basically. So here, video dura is the parameter, and it's expecting a string. I can see that. Dot the period is the default value. If you ran the script with video dir c videos, then c videos is the argument that you pass to it. If a script says name, age, color, those are parameters, then these are the categories it expects input for: name, day, age, 30, color, red. Those are the arguments in your script. These are the parameters: video dir, subtitle dir, output dir, video xts, recurse. From real use. You know, if the script is run like this: mkvvise video dir, subtitle dir, then the video dir gets parameters, like that gets the argument c enemy. That's right. So yeah, so it would say that it would pick up things from c enemy and c subs and pair them together, right? Anyways, so it put that in. So now I understand, what's being said in that line in the program. So let's also get out of this and no. New tab. Okay. Then alrighty, commandlet binding. I wonder what that means. Anyways, string video dir. So specifying that you want string, although I don't know why it uses this, but that may just be PowerShell's way of doing things. I'm gonna have to think about that for a while, though. If there are files that I'm not familiar with. Types, basically. Recurse, dry run, overwrite. Preferred subtitled language code for picking among multiple SRTs. En. Alright, so those are all editable very easily. Set strict mode, version latest. J. So if it doesn't find ffmpeg, that's what it does. Alright, so let's function normalize base name, string file name. This is for making file names easier to compare. Defines a function that, oh wait. Strict mode and error behavior. Set strict mode version latest, error action preference stop. This tells PowerShell to be stricter about mistakes like undefined variables. This is defensive programming, less gremlin leakage. Error action preference equals stop. Makes non-terminating errors act like terminating errors. In plain English, if something breaks, stop instead of limping on drunkenly. Function require exe. This function checks whether a command exists. Function require exe string defines a function named require exe, then takes one string argument, the executable name. Command get command checks whether PowerShell can find the command. If not, command throw missing dependency, exe not found in path. If the command wasn't found, throw a hard error. That stops the script with useful message. Function normalize base name. This is for making file names easier to ignore. Defines a function that takes a file name. N equals system.io path get file name without extension. Removes the file extension, converts the name to lowercase. So, right. .n equals .n minus replace, so that you're toggling replace. This cleans up formatting differences, matches runs of dots or underscores and replaces them with spaces. Collapses multiple spaces into one. Trim removes leading trailing spaces, so episode all normalize into roughly episode 0. Oh, right. C returns the clean name. All right, now strip function, strip language suffix, string. Right. This removes the language suffix from subtitle file names before matching. Function, so defines a function like taking a file name without an extension. Checks whether the name ends with any of the following suffixes. E.ing.es.spa. That means the percent means at the end of the string. So episode 0.en or episode 01.jp match. Return base no, replace en string with, as if such suffix exists, remove it. So episode en equals episode 1. Return. So if no language prefix is sentence, return the string unchanged. And then it picks the subtitle that chooses the best subtitle with multiple subtitles when multiple subtitles match one video. Defines a list of a function that takes a list of subtitled file, the preferred language code. Builds a regex like .en.st. This means the file name ends with .en.srt. Regex escapes, make sure weird characters in the string don't break the regex. See, this is me not being a vibe coder. Preferred equals candidate where object. Oh god. To lower invariant match. See, I don't understand what invariant is here, but filters the candidate subtitle files to those only matching. Convert this text to lowercase using culture neutral rules. The last part is culture neutral. It's important. It's an important weird little combin. If you have hello to lower invariant, you get, at first place it looks like ordinary lowercase conversion. Why not just lowercase normally? Because text rules can change depending on culture locale. Some language have special casing rules. The classic troublemaker is Turkish. Uppercase I. Lowercase can behave differently than English expects. If you're doing file name matching, key identifiers, internal comparisons, or anything, machine it, so you usually do not want your lowercase behavior changing because of the system change. That's what invariant is meant for. Invariant culture is the net's culture-independent formatting and casing behavior. So to lowercase using the current culture's rule. To lower invariant, lowercase using fixed culture neutral rules. This makes it safer for file names, dictionary keys, protocol addition keys. If you had, get file name with remove the extension, convert the result to lowercase. Right. That helps with what your script compares file names to see whether the subtitles belong to a video. If it used culture and sensitive casing, there's a chance that matching could behave strangely. based on systems with certain locale settings. Using to lower it vary, it says, I'm normalizing text for machine comparison, not writing prose for humans. That's the correct instinct, tiny but small. Compare the three ideas. Lowercase is used as the current culture. To lower it, case insensitive comparison, often even better than lowercasing manually. Right. Tiny example. This is going to be one of my longer videos as a result of all this because I'm in the learning mode at this point, you know. It's kind of like let's learn PowerShell here. So let's zoom in a little bit. Just so we can see a little bit better. So let's have it. You know, I did all this just not to vibe code this because there was too much that I wasn't started. You know, this I got a block of text right with the program and I didn't get it at first. So let's keep going. Right. So the user wouldn't input this. I gotta see if there's any video file names that are out there too that I can add to it because I can match that syntax in a way that would add those to it. Commandlet binding, like a proper PowerShell commandlet, it enables nicer parameter behavior and common features, right? Param that defines the input the user can pass when passing the script. String equals video direct is the folder containing the file, so that it's essentially null at the moment. You're gonna have to go in and tell it those things. I realize that I'm not saying all this stuff out loud, but yeah, I'm reading preferred subtitle language code, you know, preferred subtitle, you know, strict error mode and error behavior. So basically, you know, that just tells to be stricter about mistakes, you know, and it's telling it to stop if terminate instead of, you know, of it, you know, not getting the dependency. It's not going to keep trying to stumble along without the dependency. And so it's checking if the exe, if it needs to check if a particular function is available. So, anyways, the command that it issued, basically the winget one, will append to path anyways, which is really really useful and everything because it changes how your command line functions, so that, you know, when you call a command like, you know, ffmpeg, it will work. You know, which is really, really nice here. So this is for making file names easier to compare. Function normalize. Right. So like I said, it defines a function that takes the file name like n equals path system IO path, removes the you know, get file name without extensions, $ file name, you know, to lower invariant, removes the file extension. Right, converts the name to lowercase. Right. Example, episode 0 becomes episode 001.e. So it's removing the extension, right? And it still has to trim even further, you know. So, and then /n equals $ minus replace trim. This cleans up formatting differences, matches runs of dots or underscores and replaces them with spaces, collapses multiple spaces into one, removes leading trailing spaces. So episode underscore 0, episode dot 01, all normalize into roughly the same thing. Oh wow, I got another question. These are really, basic fundamental questions in programming, but this is something that I don't really understand at this tiny example. Function add to, if you call it with PowerShell, if you call PowerShell add to with 5, the function returns, so the result comes out back to functions, right? Take this number, add 2, and give me the answer back. Give the answer back as the return in your script. This computes a cleanup file name, which means this gives a cleanup value as a result of the function. So if the input is episode 0, the return result might be whatever is normalized. Without returning, the function does work, but it doesn't clearly hand the result back. Returning is how one part of the program says to another, here's the value we asked for. Think of it like a vending machine. You put money in, button choice, the machine gets back soda. The soda is the returned value. The function is the button press. The function call is the button press. The return value is what comes out. Right. Okay. Returning gives a value back to the code that called the function. Printing shows something to the screen user. Those are not the same beast. A return value is meant for the program to use. Okay. See, these little subtle differences are things, that are... You may see 10 on screen, but why will it not continue usefulness? So returning is for the program, printing is for the user, right? It said it had you. Nah. Output from a function can also travel through the pipeline even without an explicit return, which makes the waters a little less swampy, but the conceptual difference still stands. That little differences cause an absurd amount of confusion in programming because screens are dramatic and data flow is sneaky. Now I understand something that's been mysterious to me for quite some time now, so that it really helps. All right, so let's go back in here and to the top. Anyways, This removes the language subtext from subtitle file names before matching. This function will pick the best subtitle, chooses the best subtitle with multiple subtitles or files match one file. Defines the function that takes a list of subtitle files, a preferred language code. Right. Okay, we're speeding along to understand this. I've never coded with PowerShell, just so you know, so... Builds a regex, like, that means the file name ends with .en, that's src. Regex escapes, makes the weird characters in the language string don't break the regex. Yeah. Filters the candidate subtitle file to only those matching the preferred language. If any preferred language subtitle exists, return the first one. If none matched by the preferred language, right. So this was basically to... I had it, by the way, if you're wondering what it was that I was doing with PowerShell. This is a little code that, it remuxes an entire bunch of video files into an MKV container and then attaches subtitles to the file. That's what the script is ultimately supposed to do. But here I'm starting to try to learn. This converts a language code into three-letter form commonly used by Matroska/Plex. Function ISO 320 defines the function. Comment lines explains the purpose. MKV subtitle data often uses three-letter. The function accepts common inputs like en, and then maps them. If language is null, use empty basis. If string is null or white space, then return ing. If the input is empty, default to ing. This is a hash table matching common language models to standard three-letter codes. ES, SPA. If map container keys, left one, return map. If the language exists in the map, return the mapped value. Otherwise, return whatever the user provided as the best effort fallback. Check FFmpeg. Require exe. FFmpeg calls the earlier function to make sure that FFmpeg exists. If not, the script stops right there. Right now, we're really not vibe coding. If string is null or white space, output direct, join path, resolve path, video draw, path, MKVs out, new item, checks whether the user left output direct. So that's what I would think it would do. And then output direct, join path, resolve path, video, MKVs out. If blank, resolve the path of the video direct, create an output path inside it called, MKVs out. And so if videos are in C enemy, then output becomes enemy MKVs out. New item type directly, force path to output direct. Creates an output directly if needed. Force means don't complain if it already exists. Out null hides the normal output. Shit. My mouse just died on me there for a sec. Resolved video direct, resolved path video. These convert possibly relative paths into absolute real paths. Example, that becomes something like C users, downloads MKV vise. This makes later comparisons more reliable. Print settings, video direct. This prints a summary of the current current configuration before the processing starts. The final write text just prints a blank line for readability. Okay, collect subtitles. Index subtitles by normalized baseline force array with explains the subtitle files will be indexed by normalized name subs. Gets all SRT files in the subtitle directory. Filter star dot. Build subtitle index for each subs in at that's S in subs base. See, this is starting to make sense. The loop system IO path get file name without extension S name strip lang suffix key normalize. Oh wow! So you created a function to do all these different things, and now it loops through every subtitle file and groups them by normalized base name for each sub. You know, just take the file name without SRT. Episode 0.en equals episode 1.en. Remove the suffix language, if present. The episode 01 that is episode 01. Normalizes the subtitle base name y.x. Because normalized base name uses get file without extension, so this fake extension ensures the function treats base like a file and strips the fake x back off it cleanly. Slightly sneaky, but valid. This means that both episodes 01, right, can end up grouped under collect videos excluding output directory. Explains that it gathers videos and excludes files inside the output directory. Builds a wildcard path representing everything inside the output folder. So, MKV is out, gets all the video files, list all the files in the video folder, filter those files. Keep only the files whose extension is in the approved list. Exclude anything inside the output directory. This prevents the scripts from reprocessing its own output like a snake eating its own tail. And then bail if there are no values. If there's no video files were found, print a warning press, and then exit. No videos are treated as an error, nothing to do. .ff common, hide banner, ff common if override. Yep. Create an array with one common FFmpeg. Hide banner reduces extra startup clutter in FFmpeg output. FF common if, overwrite output without files without asking. Never overwrite index files. Depends on whether overwrite was supplied. Counters, okay, equals failed. Initialize success and failure counters. Subtitle language tag. Subtitle language to ISO. Preferred lang. Convert the preferred language into the 3-letter form for MKV subtitle metadata. Main processing loop. For each V in video, start processing each video at a time. Key, normalize base name, base. Right. So, create a normalized key to find matching subtitles. Get the video file name without extension. Build the output file name in the output folder always with MKV. Alright. See whether a matching matching subtitle already exists. Has SRT. Subs by key contains data key if SRT equals null. If has SRT equals pick subtitles by key, prefer language. So, God, no, go away. checks whether there are subtitle files matching this video's normalized name, initializes the subtitle the selected subtitle variable to nothing. If a match exists, it choose the best one. Call the earlier function to pick the preferred language or fallback subtitles. Matching subtitles, if matching subtitles exist, if args ff common build the full ffx command arguments. Now the important flags. Input equals 0 if in the video file. Input 0 equals the video file. Input 1 equals the subtitle file. Map include all streams from input 0. That usually means video, audio, maybe chapters existing in the subtitle streams too. Also include stream 0 from input 1, which is the subtitle stream. Copy video without re-encoding. Copy audio without re-encoding. Include subtitle streams as SRT in the output container. For an external SRT that is sensible because the subtitle needs to become a subtitle stream in the MKV. Copy metadata from the original video input. Copy chapters from the original video input. Set language metadata on the subtitle stream. S equals subtitle stream type at S equals first subtitle stream. Output the MK logging for subtitle case. Right host. This prints what's about to happen, which video, which subtitle, where the output goes. So write host would help tell you. It's like the print command, I guess. No matching subtitle. If there is no subtitle, it only remuxes the original video. There is no explicit .c copy, so if the original file already contains subtitle streams, FFX behavior may depend on defaults and stream types. The script's main promise is about video audio stream copy. It's not about being explicit about original subtitle streams in the no SSRT case. Logging for the no subtitle case. So there's the no matching SRT found. Prints what's it's doing when no matching subtitle exists. Dry run behavior. If dry run, if the user passed dry run, that prints the exact FFmpeg command that would be run. Prints the blank line. The count is okay. Skip actually running FFmpeg and move on to the next video. Run FFmpeg. So this line, FFmpeg args outhost. This is the actual execution. FFmpeg args, is the call precursor. Args splats the array to each element and becomes a separate command line argument. Send out fbook directly to the console. Check exit code. If FFmpeg return a non-zero exit code, it failed. Right? If it prints an error, including the video file name exit code, if failed, increment the failure counter. Otherwise, the count is successful. Blank each line after each video. Print a blank line for readability, then close the for each loop. Right? Prints the final totals. What the script does in plain English. For each video, normalize the video's file name. Look for subtitle files with normalized base name matches. If multiple subtitles match, the preferred language like en.srt. Build an FFmpeg command, remux the video into MKV, add the matching SRT and found, never re-encode the video or audio. This was done specifically for the purpose of making sure that it was, it maintained the quality. We didn't want something that would erode the quality, plus it would require a lot more heavy processing. Subtle information notes. Why normalize base name base plus x? The fake.x exists because normalized base names strips extensions internally. It's a small trick. It's a small trick to reuse the function cleanly. .c.srt is not quality loss. Subtitles are text, not video. This is not re-encoding your movie in a nasty, losty sense. It's just telling FFmpeg to store the subtitle stream in the MKV video. The script is a safe batch FFFM remixer with intelligent one-to-one subtitle matching designed to avoid quality loss and avoid the classical disaster of attaching every subtitle to every file. I can do a second pass where I notate in the script line, like, line of code explanation here, which is handy if you want a steady copy of the version of the file. Alrighty. That was just a pretty lengthy video here. It took me, 30 minutes and everything, but you just saw me use ChatGPT to not vibe code. And now I understand what returning is and whatnot, and why it's different than, how return is different than printing and everything, and, what it's for. I guess, right. Write host, print to screen only, write output, emit a value, return, send the result back to it. In some languages, those ideas are more blended together. PowerShell separates them out more explicitly, which is useful once your brain stops hissing at it. In your MKV script, lines like write host are basically status messages for you, the human. So they're there so you can see what file is being processed, what subtitle was chosen, and what output path is being used. They're not there to feed data into the later code logic. Bottom line, yes, write host is pretty much PowerShell's print to screen tool, but in PowerShell, show this to the user, and output is this as usable data are more separately separated than in many languages. That's the sneaky bit. Anyways, yeah, I don't know that I fully like PowerShell's syntax, but here we go. We're actually learning a little bit about it and everything. We didn't vibe code today. We pat ourselves on the back. We really started to understand the program. So let's look it over. So right, it's hitting the J key here, to go over it in Vim. I didn't realize MKV was so powerful. Or not MKV, I mean FFmpeg could do all these things, but now I'm learning a lot about FFmpeg, I guess, from this little process and everything, the command line arguments that I could use to do all these things with video. Anyways, I've been having ChatGPT explain a lot of things to me, like encoding problems and what could happen in video and what certain video artifact, like basically the flaws in videos. It's showing me examples of things like ringing and all the potential encoding problems that exist in it. I'm having it do that for me, and I'm kind of hoping to have it teach me how to process things in a way to eliminate them, because it's a useful skill that you know is desirable to other people.